Did you know that over the course of a day you make as many as 32,000 decisions? This might sound like a lot, but imagine something as simple as walking to a restaurant for lunch. You decide which restaurant to go to. You decide your route, which turns you're going to take to get you there. You decide how fast to walk and whether you want to make any stops along the way. You decide whether and when to cross any streets that you pass on the way there. Once you're at the building, you decide which door to enter through. And once you're inside, you decide what you want to order and how you want to pay. So even on a simple venture like this, you make hundreds of decisions that you probably don't even give a second thought to. But what if, like nearly 4 million people around the globe, you were blind? Suddenly decisions that you might take for granted become time-consuming, stressful, or even life-threatening. But that's where Project Oracle comes in. We're a multidisciplinary team applying the principles of biomedical, electrical, software, and mechanical engineering to the task of translating visual information into a form that blind clients can use, improving quality of life and hopefully preventing a few accidents along the way. So how exactly do we do that? Well, the heart of Project Oracle is the Oracle headset, which is designed to find text in the environment and read it back as audio. This allows users, for example, to read street signs, find restrooms which aren't marked with Braille, read books without assistance, and so on. Like so. Hi there, I'm James Etheridge, this is the Oracle headset, and this is what it does.
Hello world.
Pretty cool, huh? Let's see how it works. The way that it works is actually quite simple. The headset contains a Raspberry Pi Zero, which is a bite-sized computer running a trimmed-down version of Linux. Whenever it's powered on, through the onboard battery, which lasts about 2 or 3 hours, it waits for a button press. And when a button press is detected, the webcam that it contains snaps a picture of whatever it's looking at. That image is then processed through an optical character recognition suite called Tesseract, which outputs any text as a file. Finally, that file is read back aloud through the speakers via another program called eSpeak. Worth a special note here is that the Raspberry Pi Zero doesn't actually include any normal audio outs. So, in order to get our speakers working, we had to fabricate a low-pass filter and wire it in, and then change the behavior of a couple of the outputs in order to get the speakers working. So that's how the headset looks and functions now, but you may be wondering if there are any alternative designs. Well, in the early stages of the design, we actually had the processor stored separately from the camera, in a small case which clips onto the belt. We also had the Raspberry Pi 3 rather than the Raspberry Pi Zero powering the unit. We ultimately discarded this design as having everything stored in the headset rather than having wires everywhere seemed much more user-friendly. Also, the Raspberry Pi 3's power consumption was far higher than the Raspberry Pi Zero's, and at the time we felt that we didn't really need the extra processing power. Moving forward, however, we may revisit this design for one very important reason. The extra processing power would let us use the Pixie Cam. This is a camera which pre-processes images and allows for very intelligent tracking of colored objects. With Pixie, users could conceivably wear a colored glove and point to specific pieces of text that they want to read, such as items on a menu or elevator buttons. Users could also have the end of their cane colored, allowing the Pixie to direct them towards terrain that touch alone can't find for them, such as crosswalks, colored paths, and so on. We've tried doing the latter with a color sensor on the end of the cane, but we've been told by users that it changes the weight and feel too much. Pixie obviously wouldn't have that problem, so it would really revolutionize the design. This would also eliminate the webcam, the last piece of non-open source hardware that Oracle uses. Since the software is also entirely open source, Oracle could then be available for anyone with the skills and desire to make one. But that's for the future, and we'll keep plugging away at it. In the meantime, thanks for listening, and if you'd like to learn more, there should be some links in the description. This is Team Oracle, signing off.